Today we are starting our fourth module. In this module, we need to discuss about search engines, then search strategies. Some of the search strategies like Boolean search and serial search, we need to discuss about that. Then matching functions, cluster representatives, then cluster-based retrieval. These are the things we need to discuss in this particular module. First, we need to discuss about search engines. We all familiar with this terminology, search engine. We all know that what a search engine is. It is a software system that is designed to carry out web searches, that is internet searches, which means to search the World Wide Web in a systematic way for a particular piece of information specified in the textual web search query. Here we are putting search query as a text, then we want to search that query. Maybe the search results are generally presented in a line of results. That line of results that may be in different pages, like in Google. That pages are known as search engine results pages, or you can say SERPs. Search engine results pages, SERPs. The information may be a mix of links to some web pages, that may be images, that may be videos or information graphics, article, research papers and other types of files. We can search any type of files. That is, as a result of your search, these many types of files will be retrieving, or the search engine will retrieve for us. Some search engine may also have some capability to mine data from databases or other open directories. Then another important thing is internet content that is not capable of being searched by a web search engine is generally described as the deep web. That is, no search engines can search the content which are present inside deep web. The search engine maintains the following process in the real time. These three processes which are done in web search engines in order to materialize that searching process. The first thing is web crawling. Web crawling is the process from which the search engines get their information. Then after getting that information, it will index all the keywords which are present inside the pages. That is the second process, is indexing. Actually, it is the process of getting the keywords from the document. That may include titles, then that may be present in the content of that particular pages, then that may be from headings, or in the case of web pages, we will be getting the index terms from its meta tags. Some of the examples of search engines are Google, Bing and DuckDuckGo. There are lots and lots of search engines are there. Now we need to discuss about search strategies. We all know that all search strategies are based on comparison between the query and the stored document. We'll be having lots and lots of stored document or a collection of stored document, and we will be providing some query to our system. Then we will be comparing whether that query is present in this particular documents. That is what's happening in all the search strategies. Sometimes this comparison is only achieved indirectly with the query is compared with the clusters only. Here what we do is we will be splitting all these documents into some clusters, and we will be searching only in that clusters. That may be we will be searching only one document from each and every cluster. Like that, we can also restrict our searching strategy. So, distinctions made between different kinds of search strategies can sometimes be understood by looking at the query language. That is the language in which the information need is expressed. These search strategies may depend upon the language which we are using to send the query request. This query request may be of a Boolean form, or you can use our natural language, etc. etc. There are lots and lots of variations available for sending query requests. Various languages we can use. Here, the nature of this query language often dictates the nature of the search strategies. For example, a query language which allows the search statements to be expressed as logical combination of keywords normally dictates a Boolean search. This is a search which achieves its results by logical comparisons of the query with the document. In Boolean search, what we do is we can provide the queries by a logical combination of the words. Then using that search, we can find the relevant documents. From this we can infer that the search strategies may depend upon what the query languages. Hope it is clear. Now we need to discuss about the Boolean search. Boolean search strategy retrieves those documents which are true for the query. We will be having a query and we will be comparing all the documents against this query, and we will be retrieving the documents which are actually true for this particular query. Here we are expressing queries in terms of index terms or keywords. So we will be having in this query some keywords and some logical combinations like and, or not. Here for example, you can see one query K1 and K2 or K3 and not K4. This is our entire query. Here if you provide this particular query, our system will retrieve all the documents indexed by K1 and K2 as well as documents indexed by K3 which are not indexed by K4. This is an example for what? One binary search or Boolean search. Some systems which operate by means of Boolean search allow user to narrow or broaden the search by giving the user access to a structured dictionary which for any given keyword stores related keywords which may be more general or more precise. We already discussed about the term thesaurus. This thesaurus contains what? The related words of a particular keyword. So while searching that, we can also search what? We can also search the related keywords. In that way, we can broaden our search. Some Boolean search system is providing that capability to us. So if you are using thesaurus, we can hierarchically arrange the words. Means first we'll be putting one word in the query, then we'll be finding some related word, then we will be finding the related word of that second word, like that. We can arrange the entire words as a tree. Then we can search the words inside that particular nodes of the tree. So in this way you can broaden our search. Okay. For example, here in this structure, I have provided K10, that word as the query. Then K11 is more precise word than K10 from thesaurus. Means we know that one word has different meanings in different circumstances. Then K11 again split into K12, K22, K32 and K42. So upon searching this K10, ultimately we are searching what? These many keywords. That is, we are splitting K10 into 4 equivalent keywords. In this way, this Boolean search can be used for what? broadening our request. So therefore, if one has an interactive system, the search can easily be reformulated using some of these related terms. So we can reformulate our search, or automatically the system can reformulate the search and user will be getting the relevant information. So here we all know that and is intersection, not as difference, and or is union. Okay, we'll be discussing that. All these things are it is purely the logical relations. Okay. So Boolean search can be implemented through inverted file. That file structure, inverted file, we discussed already about this inverted file. It is a file structure which is used for this binary searching. Then what is the content of that inverted file? A list of which it contains a list of keywords stored in the vocabulary, and in each list put the addresses of the document containing that particular word. So inverted file will be having a file structure which has got all the keywords present inside all the documents. Then against these keywords we will be having what? The references of the documents or the addresses of the documents. So one particular query, one particular word came, then we can search in this particular data structure and we can find the corresponding documents which are being present. In like that we can retrieve the documents. So here for example, we'll be having K1 list. That means a word, one index term K1 is present in D1, D2, D3 and D4. These lists are known as Ki lists. K1 means first keyword, K2 means second keyword, K3 means third one, K4 is the fourth one. Here means K2 is present in D1 and D2, K3 is present in D1, D2, D3 and K4 is present in D1. And our search query is K1 and K2 or K3 and not K4. We need to find all the documents which are satisfied this particular query. Here we already discussed about this thing. And means intersection. We need to find all the documents which contains K1 intersecting K2. Or means union. Not means we need to take the difference. Is it clear? Okay. So first we need to find K1 and K2. K1 and K2 here. For example, here in this example, K1 and K2 will be getting D1 and D2 because D1 and D2 is the documents which are commonly found K1 and K2. Then K3 and not K4. What may be the answer? D1, D2, D3 minus D1. That means D2, D3. So as a result, we will be getting D1, D2 or D2, D3. Ultimately, the result is D1, D2, D3. So this search query will retrieve D1, D2, D3. Hope it is clear. This is the way in which the Boolean search works. Okay, so or means the union, then and means the intersection, and not means the difference. D1, D2, D3 is the result because it satisfies the query and each document in it is true for the query. That is the main important point. The retrieved documents should be true for the query. Okay. Hope it is clear. Then we need to find out the matching strategies. We need to discuss about the matching strategies. One of the basic matching strategies is the simple matching strategy. Simple matching strategy. We need to discuss about that. Okay. Here a slight modification we are doing in the full Boolean search. We are making some of the modifications. We are making some of the modifications in that full Boolean search. We already discussed about this thing, full Boolean search. Full Boolean search is, it is the, we already discussed that Boolean search thing. That is what we mean by this full Boolean search. That is, full Boolean searches, that documents should be strictly true for that particular query. Hope it is clear. Okay, so we discussed about that, and here we are trying to modify that full Boolean search in simple matching strategy. Okay, so a slight modification of the full Boolean search is one which only allows AND logic, but takes account of actual number of terms the query has in common with the document. In simple matching strategy, we will be only restricting to the Boolean logical ANDing of the query. That is, we will be only allowing AND operation only, but we will be taking account of the actual number of terms the query has in common with the document. That we need to discuss about that, how this simple matching query is implementing. And that particular number is known as coordination levels. Here the coordination level means number of terms the query has in common with the document. Number of terms a query has in common with the document. So here in this example, what we do is, for the same example as before with the query, Q is equal to K1 and K2 and K3. Here you can see only AND operations are there. AND operations. This particular searching strategy is called simple matching strategy. Here we are only allowing AND operations. Then we will be getting the following ranking. Here the coordination level means, we already discussed about that, number of terms the query has in common with the document. Here the coordination level 1 means query has one term in common with the document D4. Then coordination level 2 means two terms are in common with this document D3. And here the coordination level 3 means three terms in common with D1 and D2. If we were using this full Boolean search, we would have only got what, this D1 and D2, because K1 and K2 and K3. We need to find K1 and K2 and K3. In this example, we know that it is D1 and D2 only. Hope it is clear. In this example, K1 and K2 and K3 is D1, D2. But in that simple search strategy, we have a search results of different levels. That is coordination level. In coordination level, what we do is, we will be getting the number of terms the query has in common with a number of documents. So here, for example, in K1, K2, K3, we are having D3, D4 document which are present in K1. K1 list D1, D2, D3, D4. K2, D1, D2. K3, D1, D2, D3. So here in these three lists, K1, K2, K3, D1, D2 are the common documents. So in full search, we will be only getting this D1 and D2. But here you can see K1 list. This K1 is also present in D3 and D4. K3 is present in D3. So we will be getting that partial search documents also in these particular levels. Hope it is clear. So coordination level 3 is what? That is the ultimate results. In this simple matching strategy, user can go down for different coordination levels. So in the first level, That means the number of terms which are common in the document. Here means one means here only one term. One term in the query is common in D4. One term is present. For example, in here you can see K1. K1 contains D1, D2, D3, D4. K1 is present in D4. So only one term is present in D4. Then another, you see K3 list, here it is D1, D2, D3. So K3 is present in D3, also K1 is also present in D3. So in the query, the term K3 and K1 that is present in D3. So this D3 and D4 has got what? Two terms in common. So this coordination level 2 means it contains one term. Sorry, this D3, the D3 document has got two common terms. Here you can see K3 is also present in D3, K1 is also present in D3. So the coordination level 2 means D3 document has got two search parameters inside that query. And D1, D2 that is present in coordination level 3, that means D1, D2 contains all the three parameters which are present in the query is present in this particular document. So in this, but in like this, we can arrange the query parameters in different levels. That is what is happening inside this symbol matching strategy. So symbol matching may be viewed as using a primitive matching function. For each document D, we calculate D intersection Q. Because here we are using and, we will be getting the intersection. That is the size of overlap between D and Q. We all know that. How can we get that intersection? Each represented as a set of keywords. This is the symbol matching coefficient. Okay, hope it is clear.